All right, example 2 here, A, B, and C. I have the proportions set up partially, and then I want to talk through how this relates to the theorems. Okay, so look at the first one. Here's what I see. I see that X is the altitude. Okay, and then I see I've got 3 and 12 along the hypotenuse. So I'm going to call that part 1 of the hypotenuse, and then I'll call 12 part 2 of the hypotenuse. So what I'm going to be able to do is utilize the geometric mean altitude theorem. Okay, so the geometric mean altitude theorem, your altitude is diagonally in your proportion, and then part 1 and part 2. So I want you to look at this setup. There's the diagonal altitude, so I would have these pieces be the 2 parts. So since I already have 12 there, I'm going to put 3 in that blank. Okay, so what I do when I set these up, I say to myself, I've got the geometric mean of the altitude. And so what I typically do is I will set up my problem like this. If I'm doing the geometric mean of the altitude, that is the section I'm looking for. And then it can either be 12 and 3 or 3 and 12, because when we go ahead and solve this one, look at step 2. When I cross multiply, I have x squared, and then I'm doing 12 times 3 or 3 times 12. Okay, it doesn't matter. So take the square root of both sides, and we get 6. All right, so here's an example of the altitude setup. Okay, next one. Here's what do I see here is 8 is the altitude, and then I have the same thing here. I have part 1 of the hypotenuse. I have part 2 of the hypotenuse. So I'm going to do the same thing. So I've got the geometric mean of the altitude. So there is the first 8, and the other 8 goes here. And then there's my x over 4, or x and 4 on the other section. So it can look a little different in the setup, but it's still the geometric mean of the altitude. There's the 8 and the 8, part 1, hypotenuse, part 2. Or it can be part 2, part 1. It doesn't matter because you'll cross multiply and solve. So let's keep going on this one. So x times 4 is 4x. 8 times 8, 64. So let's divide off that 4. So I don't need to square root every time I solve. So it looks like this one I get 16. Okay, so A and B were the 2 altitude setups. The proportion solved out a little differently, but it's still the same setup. Okay, number 5. Or I'm sorry, letter C. I was looking at the 5. All right, I don't have the altitude. Do you see this? I'm missing the altitude. So here's what I see. Big triangle. Here's what you're focusing on, the big triangle. This is a leg. Okay, so I do have, this is a leg. Okay, and so this, I'm going to use the geometric mean of the leg setup. So before we go any further, let me refresh your memory. So the geometric mean leg setup. The leg is in the diagonal of the proportion. You need the entire hypotenuse of the big triangle and a section of the hypotenuse that's touching this leg. Okay, so I need entire hypotenuse. I need this whole thing. So I'm going to have to add those two together. So the entire hypotenuse I'm going to use is 5. Okay, the section touching the leg is just the 4. Okay, so I'm going to use the 4. The only reason I need the 1 is for the setup. So I've got the geometric mean of the leg. So see how it's x and x. It's going to be 5 and 1. No, 5 and 4. Excuse me. The 1 is only needed for the 5 to get to the whole length. So if I cross multiply and solve this one out, I will have x squared equals 20. Now let's practice simplifying radicals here. So if you want to do a factor tree, you can, or you can do the perfect square method. So if I do the perfect square method, it's going to be square root of 4 times square root of 5. And so I get 2 square root of 5. Factor tree method, I'm going to do 2 times 10, and then 2 times 5. Okay, there is my pair of 2's, and then my standalone 5 has to stay under the radical. All right, so just we're going to be using simplifying radicals a lot this section, so continue to work on the method that you like best. All right, let's look at the next one. Find the value of y. Let's write our answer in simplest form. Okay, I'm looking at the big triangle here. I'm looking at the big triangle. I do not have the altitude, so I'm probably not going to use the altitude setup, but I do have the leg. All right, so I'm going to do, here's where I begin. Start your proportion. So I'm doing the geometric mean of the leg. So that means the information on the leg goes in opposite pieces on the proportion. And so I need, going back, I need the whole hypotenuse and just the section of the hypotenuse touching the leg. Okay, 15 is the whole thing. And then the 4 is the piece I need, the part touching the leg. Okay, so that is the information I need. Cross multiply, so I'm going to have y squared equals 60. Square root both sides. Remember, we're doing simplified radical form. So 60 divided by 4 is 15. So square root of 4, square root of 15. And then that becomes 2 square root of 15. Okay, I just want to take a second, let me maybe over here. I just want to show you, you could possibly rewrite and re-sketch these triangles if you wanted to. So like I could re-sketch small triangle, medium triangle, large triangle. And then I'd have to add what I can see. So if I maybe the large triangle, I can see the hypotenuse is 15, and then I've got y. The medium triangle, I have my 15 is one of the legs. And then the small one, I've got the hypotenuse is the y, and the leg is 4. So it just takes a little bit of getting used to. So if we look at our setup here, let's see. Do I have everything I need? Did I miss a segment? Because I'm trying to see if I can ratio. Okay, no, here it is. It takes me a minute to look at it because I don't usually use this method. I can ratio hypotenuse to hypotenuse, leg to leg. And that's exactly what I have in my setup. I've got, I'll start with the small triangle. Y over 4, 15 over y. Okay, so it can be done the other way. It just will take you a few moments. Sometimes it's hard to reorient the triangles because if the altitude is really, really close to cutting the hypotenuse in half, you're going to have a hard time telling which leg goes where. Okay, I would like you guys to pause and try the last 3. I want you to think about your geometric mean of the altitude or leg, and then try to complete these, at least get them set up if you can, and then come back to the video when you're ready. Okay, I see the altitude here, so I'm going to do the altitude setup. I'm going to do the geometric mean of the altitude, so x and x, part 1 of hypotenuse, part 2. So solving it out, 15 and 10 is 150. So I need to break this down. Looks like, let me try 25. Sometimes when we end in, yeah, if you end in a 0, 25 will work. And 25 is a perfect square. So square root of 25, square root of 6. So I get x equals 5 square root of 6. Okay, letter B. I see leg. All right, so I'm going to do the geometric mean of the leg setup. So leg goes in the top or bottom. I want the whole hypotenuse, which is what I'm given. And then the 5 is what I need, and that is the section touching the leg. So I'm going to have x squared equals 80, square root. Now, sometimes this works when you simplify radicals. Do you see how 80, we did 16 times 5, and 16 is a perfect square? So I'm going to be able to just turn right around and break it down into square root of 16, square root of 5, and then get to my final simplified answer. Now, that doesn't always work. Like, look at the last example. 15 and 10 is not what I used, but sometimes you can use the two numbers you just multiplied. Okay, letter C. I see leg, so I'm going to do the leg setup. So geometric mean of the leg, 10 and 10. I want the total hypotenuse. So I'm going to have to add these two segments together because I'm not given the total amount. So I'm just going to have to set it up like this, add them together. And then I want the section touching the 10, touching the leg. So just the 4. So let's cross multiply. So 10 times 10 is 100. And then I'm going to have to do 4 times 4 plus k. So 100 equals 16 plus 4k. So take away your 16. So that gives me 84 equals 4k, and then divide. So 84 divided by 4 is 21, and I don't need to simplify anything further. It's not a radical, and so that's what my solution is. Okay, so 2 methods, the geometric mean theorems. So you've got the geometric mean of the altitude and the leg, or going back to the very beginning, you could, one more, you could just reorient your triangles. But that would be a lengthier process, okay? So